Greetings, this is Chemistry with Nav. In this video we're going to take a look at oxidation numbers, and in order to do that there are a few rules that we have to start with. So for pure elements, anything which is basically made up of just one type of atom, so some examples: Cl2, Na, Mg, O2, or just carbon, they will have a zero oxidation number. But if you're looking at a compound, then any group 1 species, anything in the first column of the periodic table, that's always going to be a +1 oxidation number. A group 2 will always be +2. Hydrogen is always +1, except when it's in something called a hydride, when it's -1. And oxygen is always -2, except in a peroxide, where it's -1. Now, what we're essentially doing with these oxidation numbers is sort of pretending that everything is ionic, and we're trying to work out what the charge would be on any particular atom within some compound. So if we were to have a look at these examples, S8 is just an element, so that's going to be 0. Even though there's 8 atoms in that particular molecule, they are all of sulfur, therefore that is 0. So the same applies to the nitrogen as well. That's just going to be 0. With the water, even though this is covalent, we're trying to work out what the sort of theoretical charges would be on each of those. Now, according to the rules, the hydrogen would be +1 and the oxygen would be -2. But there are 2 of the hydrogens, and if you do 2 times +1 -2, that equals 0. And a water molecule is not charged. There is a 0 charge on water, so that's what we're trying to add up to, and that's what we get, so that's good. If we apply that same idea to the H2SO4, the sulfuric acid, the hydrogens are +1, the oxygens are -2, but there are 2 of those hydrogens and there are 4 of those oxygens. There's only 1 of the sulfur. Let's just call that X. We can call it some unknown, but basically it's going to be X here today. So 2 times +1 plus X plus 4 times -2. That all comes to 0 because, again, the charge on sulfuric acid, H2SO4, is 0. There is no +1 -1 charge after it. So this gives us now 2 plus X minus 8 is equal to 0. And if you take that to the other side, X is equal to -2 plus 8, which is equal to +6. So the sulfur in that has a +6 oxidation state. Moving on to NH3, which is ammonia. The hydrogen is +1, but there's 3 of them. And we're trying to work out what the nitrogen would be. So that means here we have X plus 3 times +1. That comes to 0 because there's no charge again on the ammonia molecule. So X plus 3 is 0, therefore X is -3. So the oxidation number on nitrogen there is -3. And this next one is potassium manganate, so KMnO4. The K is going to be +1 because that's in group 1, and we said, back to the rules, we said that any group 1 element will have a +1 oxidation number. You've got a -2 there for the oxygens, but there's 4 of them. And the manganese is what we're looking for, therefore. So in this case, I have +1 plus X plus 4 times -2 is equal to 0. That's an uncharged molecule. So that means that 1 plus X minus 8 is equal to 0. So X is equal to 8 minus 1 is +7. So that's manganese in its highest oxidation state. It's in the +7. And you'll notice with these last 2, we have charges. So now this is going to change a little bit how we lay out the equation. So the oxygen is still -2, and there's 7 of them. But the chromium here is X, and there's 2 of them. And now when I do this sum, so I've got 2 times X plus 7 times minus 2. That has to come to the minus 2 charge there. So charges go 2 minus, 1 minus, 1 plus, 2 plus, but oxidation numbers always have the sign plus or minus first, so the oxidation number is minus 2. So that gives me 2x plus minus 14, so minus 14 is equal to minus 2. So 2x is equal to minus 2 plus 14, which is plus 12. So x is plus 6. So that means that each one of those chromiums has a plus 6 oxidation state. And for the ClO minus ion, you've got a minus 2 there on the oxygen, and x on the chlorine. So x minus 2 is equal to minus 1, because the charge on that ion is minus 1. So that means that x is minus 1 plus 2, which is plus 1. Which is unusual for chlorine, given that it's in group 7. We would normally expect chlorine to be a minus 1 oxidation state as the chloride ion, but here we can see that it's actually plus 1. So chlorine has a variable oxidation state. An example of chlorine's variable oxidation states can be seen here as well. So the only thing that's going to be changing throughout this equation that relates to water purification, sodium hydroxide plus chlorine making sodium chloride, sodium chlorate and water. The only thing that's changing oxidation state is the chlorine. The sodium will be plus 1 throughout, the oxygen is minus 2 throughout, and the hydrogen is plus 1 throughout. So all we really need to look at is this chlorine, where it's 0 in the first place as the element. The Na is plus 1, so that chlorine must be minus 1. The Na here is plus 1, the O is minus 2, so to make that come to 0, that chlorine must also be plus 1. And that means that we have a fairly special situation where we have a reduction in the oxidation number from 0 to minus 1, and we have an increase or an oxidation in the oxidation number from 0 to plus 1. And if you have a simultaneous oxidation and reduction of one species, that's called disproportionation. Okay, and that occurs here for that chlorine because chlorine can have variable oxidation states.